Hello, welcome to this physics tutorial on forces and motion, and this is part 1. So we're going to be looking at distance time graphs, speed time graphs, or velocity time graphs. Both are the same thing. There is a small difference between speed and velocity, and that's another thing that we're going to be looking at. And acceleration. We can also look at the same time deceleration, because they both pretty much the same, but deceleration is decreasing speed and acceleration is increasing speed. So deceleration is something that we can look together. You should be able to use the formula for speed and to be able to calculate speed, or using speed or rearranging the equation to find other quantities. And for that you will be given this in AQA exams. You will be given this formula sheet, but as I look through it, you can't find this equation for speed. So however, you got the other equations, acceleration and force, how to calculate force, and other equations are there, but there is no equation or formula for speed is given. So it's worthwhile knowing this formula. Speed equals distance over time. So this is same as speed, distance over time. And time can have any unit. So depending on what units you have for distance and time, the unit for speed changes. Say for example, the distance is measured in meters and the time is measured in seconds, which is a very common which are very common units that are used. So speed will have a unit of meters per second, which is obtained by just dividing that by this, meters divided by seconds, which are the units used to measure distance and time. Okay, so that's the unit for speed. Now let's move this equation sheet away and focus just on the formula. See, if this is the problem that we have to solve, a simple question, we have to work out the speed in meters per second. The only small adjustment that we have to make is we have to convert 5 kilometers into meters. Now whenever you have kilo in your unit and you want to convert that to meters, that K stands for 1,000. So if you can just replace the K with 3 zeros, you've done the conversion. So to convert 5 kilometers to meters, drop that K, replace that with 3 zeros and put meters. So you're replacing the K with 3 zeros. Now that has become 5,000 meters. So you've actually converted 5 kilometers into meters. Now the next stage is to apply the formula. So speed, always show the working. It's useful in exams. Show and substitute the numbers. Write the formula first if you can. So in this case I'm not going to do it, but if you're doing this in the exam, it's really advisable that you write the formula first and then you write the numbers in, substitute the numbers in, and then show the working in that way. So here in this case you have a distance of 5,000 meters, as we have just converted kilometers to meters. Now divide by the time taken, which is 100 seconds. So now this becomes 50 meters per second. Again using the same equation, but this time around we have to calculate the average speed, because we are looking at a bus traveling from A to B in 300 seconds. That's the time for the first section of the travel of the bus's journey. And then you have the distance from A to B is 180 meters. Okay, now if you look at the distance, the time taken from B to stop C is another 150 seconds, and the distance from B to C is 200 meters. So the speed may not be the same from A to B and then from B to C. However, we're going to work out only the average speed. The easiest way to do this is you work out the total distance traveled and divide it by the total time taken. And the 200 meters plus the 3 plus the 180 meters, so that becomes 380 meters the distance. The total distance is 380 meters. So you just substitute the numbers here, divided by the total time taken. So in this case it's 300 plus another 150 seconds, so that's 450 seconds. And if you work out the speed, 4844 meters per second. You can even leave it to two significant figures if the question asks you to leave your answer to two significant figures. So what that means is you round up the number to only to two significant figures. So that is that, and pay attention to the unit as well. Sometimes there is a mark for using the correct unit. A to B is 180 divided by 300. That gives you 0.6 meters per second. And if you work out the same from B to C by dividing 200 by 150 seconds, you should get 1.333. So the speed for this section is 1.33 recurring meters per second. So you can see the speed is not the same between the two sections. However, remember, you're only working out the average speed. It's one useful thing to check. The average speed is between these two speeds. Okay, so the two speeds in the two different sections is between them two. Related to speed. Okay, now velocity includes direction, and that's the only difference. For example, if you just say 70 miles per hour or meters per second, then you're talking about just the speed. Whereas if you just say 70 miles per hour towards south, now you're talking direction. You're including the direction information. Then that becomes velocity. Now this is really important in physics because sometimes the speed doesn't seem to change. However, the velocity changes. I'll give you an example. It goes a steady speed around in that circle. Now the speed is not changing here in this case, so it may be like very slow, half a meter per second or so. People may not be able to feel how they move around in the wheel. However, you should recognize that the velocity does change as people go around, because at any moment in time the speed keeps on changing. So one moment, the direction keeps on changing. One moment people in that car are going in that direction, and when they come here they're going in that direction. So to draw that in, so from when they are here they're going in that direction, but when they reach here, so every moment during that journey, during the they're sitting and the time spent on the wheel, every moment in time the velocity keeps on changing, but the speed is constant. So that's really important to understand, and there is a difference between speed and velocity. One more example on speed and velocity is, let's have a look at this yellow van here, and if that is going that way, let's call that a south. If we say that van is going at 30 miles per hour due south, we are actually talking about the velocity of that van, and it's constant velocity. If it goes at same speed, 30 miles per hour towards south, the velocity doesn't change, the speed doesn't change, it's the same. But for this car here, have a look, because it's actually going around the roundabout. If it goes, say for example, say 20 miles per hour, the speed does not change all around as it goes around, and then maybe takes that exit. Okay, let's say, so if as it goes around, its speed does not change. It remains at 20 miles per hour. But because it goes around in a circle, every moment in time it changes direction. So its velocity keeps changing. And it's really important to understand that speed doesn't change, but velocity changes. Let's have one last example of where you have to rearrange an equation, and you should be able to either rearrange it straight away to find whatever you want. Say in this case, if you want d, the distance traveled by an object and something that's moving, you need to rearrange this into speed multiplied by time, cross multiply the t over in that way. So distance, if you want distance, it's speed times time, or either that, or you make sure that you remember how to use a triangle. So in this case, the d goes on top, and the speed times time that you multiply together goes at the bottom of the triangle, and you draw a line to separate them. So the way to use that is, say, if you want the speed, so in this case, you just hide the speed and you get the formula as d divided by t, distance divided by the time. And if you want the time, you have to divide distance over speed. Okay, so in this case we're going to use this formula, either what you follow this way or the triangle way. We're going to use we need to rearrange this equation. Okay, so as a speed given, speed of the cheetah, although the question does not say it's the speed, we should be able to recognize from the unit meters per second that it is a speed. Now, what will be the distance? So we have to work out the distance. It's useful to underline the important quantities that is mentioned and it's asked in the question paper. It's really useful to annotate your question like this. Okay, so in 8 seconds, so the time is given here, and distance is being asked. So distance is a question, time is given. You've also got the speed given. So obviously, so if you want this, if you want to find out the distance traveled, as you can see, you can hide that, or you can rearrange this equation, speed times time. So what you get is, remember to write down the answer. So for the answer for the part 1 of this question is distance equals speed times time, speed multiplied by the time taken. So in this case the speed is 70 meters per second, and the time taken is time given is 8 seconds. Okay, so we're working out the distance traveled. So this is, so that's 560 meters. Now notice the unit here. Now because we're working out the distance, it has to have a unit of meters, and that comes from the speed unit that's given here. This unit here should match with the unit that's given in the question paper. So make sure in the question, so make sure these units actually match. Now let's work out how long. So you're asked to, the second part of the question is asking you to work out the time, and we already know the speed here. So speed is given, and your the distance is given as 450 meters to reach. So distance is given, so you can annotate the question like that. So what you need to work out is time, t. So in this case you have to hide the t, or rearrange this equation to get the t, whichever way you are comfortable with. Distance divided by the speed. So in this case, just write out as usual. So this time around I'm going to just use the number or just the formula in short form. So distance over speed. I want the time. So because the question is asking how long is it going to take. The distance is now 455. Divide that by the speed, which is already given over here, 70 meters per second. So divided by 70, that gives you the answer. So you should have got 6.5 seconds. Notice the unit here. This time it is seconds because we are working out the time taken for the cheetah to reach its prey, who is at 450 meters away. Okay, so it is seconds, and again you have to check and make sure that it matches with the unit of the speed. So that unit is from there. So now let's have a look at what acceleration is. Acceleration and deceleration both use the same formula: change in speed divided by the time taken. Now you may remember acceleration is for anything that is increasing in speed, speeding up, and deceleration for anything that is slowing down or losing speed or decrease in speed. You know, change in speed is measured in meters per second. So let me write the unit for change in speed here. And then we're going to divide that by the time taken. Time has a unit of second. So I'm going to divide that by another S, which is S stands for seconds. Now, if you divide this by meters per second by second, what you get is meters per second square. Okay, and that is the unit for acceleration. So let's apply this formula. Let's see how we can solve questions on acceleration using the formula. Now, let me remind you, acceleration A equals the change in speed, which is given in your exam paper in that way. Like the formula sheet will have that in it. So V stands for the final speed, and so V stands for final speed, and U stands for the initial speed, which is the speed that you start off with. So that essentially gives you the change in speed divided by the time taken. And as you've just seen, the answer, the unit is in meters per second square. But if you look at the question here, the distance is given, the speed, change in speed is given in kilometers per hour. So we need to convert that into meters per second first before we can give the answer in meters per second square. Okay, so kilometer per hour is not the unit we want. We want to convert the kilometer to meter and the hour into seconds. Okay, so the change in speed is 130 kilometers per hour. So as you can see, it goes from 0 to 130. So converting 130 kilometer, if I drop that kilo, I should replace that with 3 zeros as we've seen before. So you have 130,000 meters, and this happens in an hour. So if you convert the hour into seconds, so every hour is made up of 60 minutes. So I go 60, and each 60 is made up of 60, each minute is made up of 60 seconds. So that would give me the speed in meters per second. So that gives you 36.1 meters per second. So that's a change in speed. Now remember, when you divide this, you need to make sure that you divide this number by the product of this. You know, if you divide this number, which is 130,000, by 60 and then multiply by 60, you'll get the wrong answer. So make sure that you do this first, multiply these two numbers first, and then with the answer divide into that 130,000. Or better still, if you're using a scientific calculator, you can use a bracket, and that way you can't get it wrong. So that, anyway, that is the answer. Now once you have the change in speed, the answer is pretty straightforward. So A is now the change in speed, which is 36.11. In your calculator you did get 36.11. Divide that by the change in time, it's 12 seconds. So now you get the acceleration as is 3.0. So if you want to go for two significant figures, it's 3.0 meters per second square. Okay, let's have a look at this problem here, and as it a good practice to underline what's given here. So you can see A is given here. Okay, so and also T is given, the time is given in seconds, and you're asked to work out the speed, so make sure that you underline these things. It's always a good practice to underline. So you can also annotate your question like this. So S is something that we need to work out. So that's a question mark. So A is given, T is given. So as you know, the formula for this is given in the exam. Is like this: V take away U divided by the time taken is the acceleration. So in this case, you need to rearrange this formula. It's better to think of this formula as A equals C over T. The C stands for change in speed. Now this allows your rearrangement becomes easier. Now as you can see here, you can rearrange that in the triangle if you use the triangle to solve problems like this, to rearrange, and this becomes A times T. So you just cross multiply the T over to this side. So C, which is the change in speed, is A times T if you cross multiply. So now getting back to the problem, C equals A times T. Always show your formula first before you work out. And A in this case is 0.6 and the time is 20 seconds. Okay, now that equals 12 meters per second. Now remember, you're working out the change in speed. Now you need to know the initial speed, and this, because it says rest, the initial speed u equals 0. So if you want to use the formula, go ahead and use it. You can get the same answer. What you got is the change in speed. Now add that to the original speed, you get the new speed. So in this case it's the same because your original speed is 0. Okay, you can actually try to solve this problem and then check the answer at this stage, knowing the quantities that's given. Now you have the speed, initial speed, so that is u. It's make a note of this, it's already moving at this speed, and it accelerates. So A is given 6 meters per second square, that's A, and T is given here 5 seconds. Okay, so you can use this formula, V take away U divided by T equals A. Now you're asked to find this V here. So if you can rearrange that formula and get V, try that and then look at the solution. Now in this question, it's you're being asked to find how fast it will be moving at this point at the end of this 5 seconds. So you're asked to find the V here, which is the final velocity. So you can do this in many ways. The best way to solve this is in this way: change in speed, which is V take away U. So I'm going to replace that with C. This is much easier than dealing with this and rearranging it. So changing speed divided by the time taken equals acceleration. I'm just going to substitute the numbers in here. The change in speed is something that we don't know because we don't know the final speed. We don't know that speed. So we can't put the change in speed yet. Divided by the time taken, 5 seconds. But we have the acceleration, which is 6 meters per second square. So the change in speed is going to be now C equals 6 times 5. Okay, so that's going to be 30 meters per second because we are talking about speed here. So as we are talking about the speed, the unit is in meters per second. So this is the change in speed. Now it was already traveling at 70 meters per second. So all you have to do is add that to this value of 30 meters per second. So 70 plus 30. Now the speed after this 5 seconds is going to be 100 meters per second. I hope you pause that video and try that yourself. Now you can check the answer. Okay, so in this problem you can see what is given here. I've changed some of the typo here. A ball is thrown vertically upward at an initial speed of 30 meters per second. So what is given here is U is given. It will decelerate at a rate of 10 meters per second square. So what's also given is a, but in this case it's minus a is given. Okay, because it's decelerating, we can say that is negative. Okay, it will decelerate at a rate of 10 meters. How many seconds will it take for the ball to stop? Now, as you know, if you throw a ball straight up in the air, vertically upwards in the air, it will stop when it reaches at its top, and then it starts to fall down back towards the earth. Okay, so we know that. So we have the initial velocity here as u, given in the question as 30 meters per second. Okay, so 30 meters per second. And the final speed v here, when it reaches the top of its travel, it's going to be 0 meters per second. Okay, so we can use this formula. v take away u divided by t gives you the acceleration. So in this case, v is 0. Take away 30, that's the initial speed, divided by the time taken, we don't know the time, equals a. So a being acceleration. Or you can just put simply, instead of using that, you can just put the change in speed here for c as minus 30. That's perfectly okay. Because if you can imagine that it goes from 30 to 0, the change in speed is negative, it's minus 30. So you can just, instead of using the formula, you can just put change in speed as minus 30. Now, if you rearrange this equation, instead of a, I can write, so there's 10 here. So I'm going to put 10 instead of a, 10 meters per second square. And this is also a minus 10, if you remember. So it's minus 10. So it's, to continue from where I left, it's minus 30 divided by t gives you minus 10. Now, I've just rewritten that equation in a simplified form here. So t can be transferred over here, and minus 10 comes over here, and that gives you t equals minus 30, which is this 30 here, divided by minus 10. So what do you end up with? T equals 3 seconds. Because remember, t is time, and we are looking at how long will it keep going until it stops and keeps and comes back down. Okay, so you can clearly see it takes 3 seconds up, and then stops and comes down. So totally it'll take 6 seconds for it to come back, but the question is asking when the ball will stop if it's thrown upward with a 30 meters per second initial velocity. There are two main types of graphs. Let's see how we can use these ideas of speed and acceleration to interpret graphs. Distance time graph is one type of it, where you have on the x-axis, you should have noticed that you have the time, and on the y-axis it's empty, so I'm going to put d, distance in meters. D stands for distance in meters. Okay, so what we should be able to say is the difference between the types of graphs, distance time graph, the information that you can get from them, and how you can interpret that. Okay, so you can straight away see this object is moving 2 meters in 1 second and 4 meters in 2 seconds. So it's got a steady speed. Now, the gradient of a distance time graph gives information about speed. So that is really, really important. The gradient gives information about speed. Okay, in a distance time graph. It's different for a speed time or velocity time graph, but it's really important for you to make a note of that. Okay, so how we can work out the speed, it's pretty straightforward here. As you can see, it's moved 4 meters in 2 seconds. So to work out the gradient is pretty easy. You can divide 2 by 1 or 4 by 2. So speed is now equals 4 divided by 2, or 2 divided by 1 gives you the same information. So 2 meters per second. Okay, and you also know that it's steady speed because the gradient is not changing. If it bends that way, as we look at, we'll look at some other graphs which it does. If the gradient changes, then we know the speed is changing, which means it's accelerating or decelerating. We'll look at that later. So for now, you can see the distance time graph, gradient of that gives you the speed. Okay, so let's have a look at this graph and make sure that we have the D here. Same, we're going to consider this as a distance time graph. And you can see the speed of this is now 4 divided by 1. So in this case, the speed is 4 divided by 1, and that's 4 meters per second. You can easily see that this gradient is smaller and that is much steeper. Steeper the gradient, the faster the object is moving, and that's true for distance time graph. Do not confuse this with the speed time graph. In a distance time graph, gradient gives you the speed. The steeper the gradient, the faster the object is moving. Okay, so what about this then? So because it's not going anywhere, you can see the line flat here on the x-axis. So that shows that the object is not moving at all. So the speed is 0 in this case. So speed is 0 meters per second. Okay, and this on this graph over here, you can see the object is going, the displacement is what matters. The distance is 4 and that happens in 1 second. So the speed again is 4 meters per second, just the same as this one, only the distance is decreased. So it's the object is coming from somewhere else towards you. Okay, so the speed is the same for these two things, and you can see that the steepness is pretty the same, only this has got a positive gradient and the other one has got a negative gradient. Let's have a look at the other types of graph. Other type of graph is a velocity time graph. So I'm going to put a V. You can also put S there for speed. So let's have V. Sometimes you're given S instead of V. So it's either one of this. It's the same thing. Obviously, there's a difference between speed and velocity, but in a graph situation, it is interpreted in the same way. Okay, so in this case, what information can you get from that? What you get is the change in speed. So you can see here, initially the speed is 0 for this object, whatever it's moving, and in 2 seconds, the speed is now 4 meters per second. So what that means is it shows the change in speed. So this is showing the change in speed, and this is given that the x-axis gives information about the time taken for that change in speed. So the gradient actually gives you the acceleration. So in this case, the gradient is acceleration. So A for this graph here is 4 divided by 2, and that gives you 2 meters per second square. Okay, and for this one, the speed is 0. Okay, be careful with the graphs like this, because if the same line is drawn here, then V equals 2 in this case, because the speed is not changing. So we'll look at some other examples in a while, but bear that in mind. So V equals 0 for this object, which is on the x-axis, but V equals 2 for this object here. Okay, so for this, the speed is 2, and for that it is 0. Okay, so what about here? Now you can see 4 divided by 1, so the acceleration in this case is 4 meters per second square. Okay, so you can see the steeper the gradient, the acceleration is bigger. So in this case, it's less steeper than this. The bigger the gradient or the steeper the line is in a VT graph, in a speed time graph, then your acceleration is bigger. Now in this case it's deceleration. Same as here, but this time it's 4 meters per second square. 4 meters per second square, but in a negative direction. Okay, so you put a minus there. So all this illustrates is you need to pay attention to what type of graph it is and interpret the graphs differently. If it's a distance time graph, your gradient gives you the speed, and in a speed time graph, your gradient gives you the acceleration. Okay, so what can you say about these two graphs here? You can see the distance is not changing. This is a distance time graph first of all, and this object stays at 4 meters per second all through this time. Okay, so it's not moving anywhere. Basically, the speed is 0 for this. Now, as you know, the distance time graph, the gradient gives you the speed. In this case, the gradient is 0. So speed is 0 and it's not 4. Okay, so be very careful when you're given graphs like this and you're interpreting the graphs. You have to pay particular attention to the what's given there. Here in this case, again, speed is 0. Okay, let's have a look at the same graphs, but in if the y-axis is changed to velocity. So here we go, you got the velocity now, or the speed, or s, you can put s there. So this is the speed time graph or the velocity time graph. Okay, now in this case, can you see the meaning is totally different? If it stays level like so, stays flat like so on 4, this actually means the speed is not changing, it stays at 4 meters per second. So obviously, I have to put the units there. So the speed here is 4 meters per second, and in this case the speed is 2 meters per second. You can appreciate how it is different by just changing this into a v. The meaning is different. Okay, now these two objects are not accelerating, and that's another information you can give, because the gradient is 0. When the gradient is 0, acceleration is 0. That means it's going at a steady speed, either that or it's not moving at all. If the line is drawn here, that means the speed is 0 and it's not moving at all. But if it is here, this object is moving at 2 meters per second and the acceleration is 0 because the gradient is 0. So let's interpret a slightly more complex graph, but with the same idea. So as you know, first thing to notice is that this is a distance time graph, and it gives the gradient gives you information about the speed. As you can see, from the start up to like 50, what's this, 60 seconds, 70, 80, 90, 100. So up to 60 seconds, it's having no change in speed. It's a steady speed. Remember, a straight line means steady speed in a distance time graph. Okay, and then for another 30 seconds it's not actually going anywhere, because the distance stays the same at 20 meters, so it's not changing. And then you can see it's accelerating between the two because the gradient is increasing. So if you look here, the gradient is lower here and then it's increasing, and then it's going at a steady speed in this section here. So if you make sections here, A, B, C, D, and then E, F. Okay, so you talk about these sections. Now A shows steady speed because it's increasing distance at a steady rate. Okay, and as you know, in the gradient of a distance time graph gives you the speed, and the speed is not changing because the gradient is not changing. And then gradient is 0, speed is 0. Gradient is increasing in this section, really important, it's accelerating. Okay, so if you see a curve going sloping upwards and the gradient is increasing, you can say the speed is increasing. And remember, that's only for a distance time graph. And then we have a straight section, steady speed here. Now section E shows the gradient is decreasing. That means the speed is reducing. And again you have a flat section F, which means it's stopped. So this if it is a roller coaster ride, and you can see a steady speed and then stopped, and then an acceleration, steady speed, deceleration, stopped. So that is what this graph is describing. Okay, so let's annotate this. Okay, there you have it. So you've got steady speed here, stopped as you have gradient 0, accelerating in section C, section D, steady speed as you have a straight section here, and then the gradient is decreasing in this section E, so it's decelerating, and F is where the gradient is 0, so the object is stopped, or if this is a roller coaster, it's stopped. The other thing you can do with a distance time graph is actually can calculate speed for different sections. So let's look at the straight sections from A to B. You can see it's covered a distance of 20 meters. So the speed for that section A is 20 divided by the time taken. So you can go here, you can see that is how long it's taken, 60 seconds. So 20 divided by 60, and that gives you 0.33 recurring meters per second. Okay, so you can work out the speed from straight sections. And another example here, you can see D, there is a straight section here, so we can work out the speed between these straight sections. It's pretty straight, nearly straight. So here we have is 120, and that goes up to 150, so that's about 30 seconds. 20, and you can see this distance from here, 120, 130, 140, 150, so that's 30 seconds. And the distance traveled is, if you go that way, it's 40 here. Yeah, so that's 40. And then if you go from this point straight this way, so it's about 22, 24, 26, 28, 30. So that's so that distance is 22, 24, 26. So we have 26 here over there. Okay, so the distance traveled is between these two. Okay, so we'll have to work out the distance traveled. So the distance from here to here is 14. So the speed for this section D is 14 divided by 30 seconds, and that gives you a speed of 0.46 recurring. Now you can see here the speed for this section A is 0.33. The section D has a speed of 0.46. You should also notice that this section D is slightly steeper than A, and that is reflected in the speed. So you have a higher speed, a steeper gradient. In a distance time graph, a steeper gradient only shows it's traveling at a faster speed. This graph is a speed time graph, and you can imagine this describes the movement of a go-kart in a race. So you can see three sections, distinct sections here. Let's label them as this one is A and B, C. So you have three sections here. Okay, so as you know, in a speed time graph, the information that you can get from this is the gradient gives you the acceleration, and you can actually work out the acceleration in this three section. And this is much steeper, less steeper, and then it's zero acceleration. This doesn't mean it stopped. Because the gradient 0 only means that it's traveling at a steady speed. Now let's have a look at section A. Now you can see in 6 seconds it's traveled 9 meters. 6, 7, 8, 9 meters. So you can actually work out the acceleration for this section by using the formula that you already know. So A equals the change in speed divided by the time taken. I'm only working out for section A. Then you can see the change in speed is 9 divided by 6 seconds, and that gives you 1.5, and this is acceleration, so meters per second square. And if you did the same for B, you have to be careful because it starts here, the section B starts here, and it finishes over here. So it's 32, take away 6 this time. So that's taken 30 seconds. Okay, so this time it's taken 30 seconds for section B. Okay, now we also need to know this change in speed for this section, and it starts here. Okay, so section B, so from there to over here. So from here to here, so from 22 take away 9, that gives you 13, and that's the change in speed. So I'm going to write that here. And the time taken is from here, from 32 to 6 seconds, and that gives you 26. So the acceleration is 0.5 meters per second square. Again, you can see it gives an information about acceleration. You should also notice that this is steeper, so the acceleration is higher. So the speed is changing at a higher rate. In fact, it's 1.5 meters per second. Every second it's increasing by. And in this case, in section B, it's slightly less steeper than this. The gradient is smaller than A. So B's gradient is smaller than A. And as a result of that, you have a smaller acceleration. As you can see, 1.5 is for A, 0.5 is for B. A smaller gradient only means smaller acceleration. Another thing you should be able to do is work out the distance traveled. And remember, this you can do only with speed time graphs. You cannot do this with distance time graph. All you have to do is work out the area covered by sections of the graph. Then you have the distance traveled in 6 seconds. For example, this triangle, so the area of this triangle here, that will give you the distance traveled in 6 seconds. And as you know, the formula for the area of a triangle is A equals half times base times height. What you have is half of what you have here, which is from here to here, that's 6. So I put 6 here, times the height of this triangle is 9. So that gives me the distance traveled by this go-kart in the first 6 seconds. Okay, so let's have if you work this out, you should get this distance traveled. So as you can see, half of 6 is 3, so I put 3 there, and then 9, that gives you 27 meters. You can also work this out on a calculator. Okay, so you get 27 meters as we are working out the area. In this case, gives the distance. So and again, you can also work out the distance traveled by the go-kart in section B. So that goes from here up to there. So that works out to 26 seconds from here to there. So that is 26 seconds. Okay, so we can divide this into 2 sections. So I'm going to do that right now. You can see that I have divided the area that I'm interested to find the area of, to find the distance, into 2 sections. So that's a triangle here and a rectangle here. So if I'm able to find the area of these two, for a triangle I should use the half BH formula, and for the rectangle it's the width times the height. So as you can see, this triangle starts here at 9 and then finishes at 22 meters per second. So the height of the triangle is 22, take away 9, and that gives you 13. So the height of the triangle is 13 here, and the base of the triangle is 26, the same as the base of the rectangle. So we're going to use 26 times 13 times half. Half of half times, so the area of the triangle is half times 26 times 13. So that's 13 times 13. That gives you 169 meters as we are working out the distance traveled. Of course, we are calculating the area, but the area gives you the distance traveled. Okay, so doing the same kind of calculation for the rectangle, you multiply 26 times 9, and that gives you 234 meters. So 26 times 9, that gives you 234 meters. And so the total distance covered in section B is you add this to that, and that gives you a total distance covered in that section of 403 meters. Now I understand this is pretty hard for some of you who are not very good with calculations and maths and areas of triangle. This part of the tutorial on this topic is only meant for higher level students, and this is often asked at higher level paper, on the higher level paper. You should be in a position to say now which one of these cars are traveling is traveling at a steady speed. Have a moment to think about that. Ready? It's actually that one. Because you can see the gradient is not changing for that green car all along, so that is traveling at a steady speed. Now which car is not moving at all? Moment to think. And this is actually the purple car. Speed is 0 for that because the gradient is 0, and remember we are looking at a distance time graph here. Okay, so which car is actually accelerating and then reaches a steady speed? You should be able to figure out that by now. It's actually that one there, the blue car. So that is accelerating here. As you can see, the gradient is increasing and then it reaches a steady section. Okay, and for that car it's actually has a steady speed at a start, and then it's decelerating coming to a stop. So that's that one. See if you can describe the speeds, how the speed is changing in these different sections. Now you can pause the video, try to think of how to describe each section A, B, C and D, and then continue the video to listen to the answers. Okay, so you should have said A is called an acceleration. The car, if this is a car, it's accelerating, and then a steady speed. Section B shows steady speed acceleration, but the acceleration of C is smaller than A, and then a D, steady speed. So mind you, this is a speed time graph, so this is not zero speed as in the case of a distance time graph. Okay, you should also be able to work out, say, the acceleration for section C. Try to work it out yourself and then continue the video. So the change in speed for this section is 12. Actually, it's not 11. Popular mistake is that each division is not 1 always. In this case, it goes up in 2s. So from here to here, the change in speed is 12 meters per second. So I'm going to put 12 here. That's the change in speed. And the time taken is 10 seconds. So I'm going to put 10 here. So the answer is 1.2 meters per second square. You should also try to work out the distance traveled by this car in section A. So you should have worked that out as the distance is the half of the base times the height of the triangle for section A. So half of the base, which is up to here, which is 6 seconds. So 6 times, if you look at the height, it's 18. So half of 6 times 18, and that should give you 54 meters. You should be glad to know that you have now reached the end of this revision video. Okay, so you should take a break. You must be pretty tired going through all that stuff. Well done for reaching the end.